Fahrenheit is a third temperature scale. Plot the data. No. All right. Yes. Plotting is fun. Let's do it. Plotting graphs. Derive the equation for the relationship between Fahrenheit and Celsius. We already did this in some other video, but we'll do it again this way. Let me see if I can make a. Okay. All right. Oh. And then there's my Y. There's my X. All right. I don't think I've ever used that line tool. There's my X. Let's call the Y Fahrenheit. Make that uppercase. And let's call the X Celsius. All right, and let's plot these things. There's only five of them, not too bad. I'm gonna go with a little off color here. Let's go with blue. All right, we got a 0. Love zeros. All right, so 0 on the x-axis, which is the Celsius, is, let's put some markings on here. Yeah, so Celsius goes all the way up to 200-ish, so we'll call that 200. A little past, but it's okay. Make some room there. This is the origin, so that'll be 0. And Fahrenheit goes all the way to 400. All right, we'll definitely not draw on the scale. This will be 400. And then we got a little room up there for that stuff. All right, and we'll just label this 200. Put some minor ticks there for the 100s and 300. And let's label that as 100. And that is good enough. Let's go. All right, so now we can plot this. Zeros are the best. 0 on the x-axis is right over here, and that's about 32 up on the y is right around there. So there's my point for that. Okay, let's just work our way up. All right, 37 is right around right there maybe, and that's almost 100. So that's right around there, a little less, maybe around there. Okay. All right, next one. 100, right on this. And that's going to be a little over 200, right around there. Okay. And then the last one is like 220, so a little bit there-ish, and 430, right around there, maybe. All right, there-ish. All right, and then the negative one is negative 30. So this is like about 100, right? Negative 100, maybe there. And then we're going down 30-ish there. About the same that as this point is up. I'm trying to go down. All right, got a lot of stuff on my screen. Let's make a line here. Try to connect these dots. Pretty good. All right. I just freehanded all this, so that's not bad. There's our line for Fahrenheit versus Celsius. So we're going to need an equation for that, right? So that's y equals, we can do y equals mx plus b form. We can get that. Just pick 2 points. I'm going to pick the points with the 0, definitely. I'll do that one. I'm not going to do the freezing point and boiling point of water because we already know that. All right, so to get the slope, which is m, is going to be the change in y over the change in x. That's rise over run, sometimes you say. All right, and we know in the y direction, so we take the boiling point minus the freezing point. That's 212 minus 32. That's just that. Okay, so 212 minus 32 is when water freezes. All right, that's going to give you 180. And then the x-axis is the Celsius scale, so that's just 100 because water freezes and boils 100 degrees apart. All right, that's just this part right there. All right, so we got the rise over the run. We can reduce 180 over 100 to 9/5. Or if you want to use decimal form, you can just move the decimal over twice and you get 1.8. Right, so that either one is fine. Or let's do that, 1.8. I don't need that 0. Okay, so now we got our formula here. Y is equal to, oh, you know what? Let's label the Y. The Y is the Fahrenheit scale. So Y is F, Fahrenheit, is equal to mx, which is 9/5 is the slope, x is Celsius, right, and the y-intercept is 32. Because that's where we did this earlier, right? X is 0, and when x is 0, it intercepts the y-axis at 32 degrees. So water freezes at 32 degrees. All right, or if you want this in decimal form, you can do Fahrenheit equals 1.8 degrees Celsius plus 32. So either one of them.